Okay, today we're going to talk about section 2-7, which is on parent functions and transformations. The parent graph, which is the graph of the parent function, is the simplest of the graph in a family. Each graph in a family of graph has some similar characteristics. So we have four main families of graphs that we're going to look at today. The first one is called the constant function. Okay? The characteristic, every member in this family has this characteristic. It's a straight horizontal line. And everybody in that family will look like this. There'll be y equals a, where a is a real number. It'll be like y equals 2. If I was to graph that, okay? Well, if you think about it, we have slope-intercept form, y equals mx plus b. Notice there's no x term. The reason there's no x term is because the slope of this line I want to graph has a slope of 0. And lines that have 0 slope are horizontal lines. It has a y-intercept of 2, so it crosses at 2. Okay, there will be that line right there. Every member that has this y equals a number will be a horizontal line, and it belongs to this family called the constant function family. All right, let's look at the next one. This one you should be really familiar with. The linear function family. Okay? The characteristic of it is it's a diagonal line. Okay? A diagonal line. So it can't be a horizontal line, it can't be a vertical line. It has to be a diagonal line. It can't be horizontal or vertical. And the most basic member of this family, it's called the parent of that family, is the line y equals x. So if we have the line y equals x, this is the parent of this family, the linear function family. Well, again, we know how to graph this. It's in the form y equals mx plus b. It doesn't have a b, so it will begin at 0. The slope of this line is 1 over 1. So up 1 over 1 and so forth. So this is the parent of this family, called linear functions. Okay. Next one I want to look at is the absolute value function. We just looked at that. We just learned how to graph absolute value equations. Remember, all the ones that we graphed, they were all V shapes. Okay? And the most basic one of this family is this equation here. Y equals the absolute value of x. It would be this graph right here. This is the parent of this family. All the members in this family resemble the parent, but might look differently. They're all going to be V's. And remember, some of these members might open upside down. Okay? And then the last group we're going to talk about, we'll talk about absolute value. The last group we're going to talk about is the quadratic function. The characteristic of it is a curved parabola. Okay? It looks something like this. It looks more like a U than a V because it curves at the bottom. And the most basic one of this family is the equation y equals x squared. All right, so let's see what happens when you add numbers to the parent equation. What happens to the graph? All right, so you look up here on the screen here. This is the linear function family. We got y equals x. Remember, this is the parent. This is the most basic graph of this family. Okay? Well, here are some members of the family over here. All of these belong to the linear function family. I want to know what happens to the parent graph when we add numbers to it. So if you look at the first one, y equals x plus 3. I graph that over there. What did it do to the parent graph? Did it change the slant of it? No. Did it change the location of it? Yes. So basically, what it did was it took every point on this line and moved it up 1, 2, 3 units. If you just pick a point on this line, go up 3 units. 1, 2, 3. Make a point down here. Up 3. 1, 2, 3. It moved all the points up 3 units. So this is a translation, 3 units up. So adding a plus 3 to the parent graph translated it up 3 units. Let's write that out. A translation, 3 units up. All right. Let's get rid of that one. And again, let's start with the most basic graph of the family, the parent graph, y equals x. Let's see what happens when I put a 5 in front of it. What's going to happen when I put a 5 in front of it? Well, it doesn't change the location of it, right? It's still starting at 0, 0. Both of these graphs are starting at 0, 0. But the red line is now steeper than the purple line. So it made it larger. It stretched it out. It's like the transformation that's being done is a dilation. When you go to the eye doctor and they drop things in your eyes, makes your pupil larger. Okay? So this is a dilation. Made my line steeper. All right. What's going to happen when I stick a negative sign in front of it? Let's see. Let me get rid of this. Let's grab this one now. What happened to the purple line? Again, it's starting at the same point, but if you look at this point right here, that point is now down here. If you look at this point right here, it's now up here. What this is an example of is a reflection. I'm reflecting the purple line over the x-axis. It's a reflection over the x-axis. So that negative sign in front of the parent graph reflects it. Okay, so now we know what happens when you add numbers to the parent graph. On this last example, 2 numbers are added. So make a prediction. Make a prediction. What do you think is going to happen? So what's the negative sign going to do? What's the -3 here going to do? Okay, so if you start at the y-intercept, the -3 here translates your graph down 3 units. So it takes this point here and move it down 3 units. 1, 2, 3. Okay? Let's pick a different point. It'll be easier to see what's going on here. Let's just pick this point here. Okay, so the -3 is going to move it down 3 units. The minus sign is going to reflect it. Okay? So I'm going to take this point here and reflect it over the x-axis. So 1, 2, it's 2 away from the x-axis. So its reflection will be right here. But then this -3 will move it down 3 units. So it's going to take this point after you reflect it and move it down 3 units. 1, 2, 3. So there's the new location. Again, let's see, let's pick another point. Let's pick this point. So the -x reflects it. So how far away is it from the x-axis? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? So there's its new location. And then the -3 will move it down 3 units. 1, 2, 3. And there it is. So if you want to write this out in words, it's a reflection over the x-axis. Then a translation 3 units down. All right, so that's a linear one. Let's see. Let's do the absolute value ones next. So again, what I got over to the right is the parent graph. Y equals the absolute value of x. Okay? Let's see what happens when I add a +1 inside that absolute value. Well, if I'm going to graph this, here's what the graph would look like. So here's the graph of that equation. So what did it do to the parent graph? How could you get the black graph laying on top of the blue graph? You would have to move the black graph over 1 unit to the left. So it translated 1 unit to the left. So adding a +1 inside there, move the graph 1 unit to the left. Okay? Let's see what happens when we put a number in front of the x inside the absolute value. Well, let's graph this one. Let's graph y equals the absolute value of 2x. Well, the vertex will be at 0, 0. And here's what the graph would look like. So what did it do to the parent graph? It changed the size of it. So whenever you change the size, that's a dilation. So this is a dilation. It made the graph steeper. Okay. All right, last. Let's look at the last one. So the parent graph is y equals the absolute value of x. So if we look down here, there's not a number in front of the x. It's not a number in front of the x. So that means we're not changing the size of it. Size is staying the same. you want to change the size of it, you put a number in front of it, like we did here. What did this plus 1 do it? This plus 1 moved it to the left. So what do you think the negative 2 is going to do? It's actually going to move it to the right, 2 units to the right. And then the negative 3, the number on the outside affects it by moving it up or down. So this is going to move it down 3 units. So if I wanted to graph that one, I'm just going to trace over the parent graph. And then I want to use what I know about how the numbers affect the parent graph. So we said the -2 will move it the -2 will move it 2 units to the right, and then the -3 moves it down 3. So this will be the location of your new graph. Okay, let's do one more example here. Let's graph this one. Y equals negative absolute value of x plus 3 minus 1. Let me erase this. Let's graph this one in red. So let me trace over the parent graph. Okay. So we should know what the plus 3 is going to do. If it's a minus number, it moves it to the right. If it's a positive number, it moves it to the left. So this is 3 units to the left. The -1 will move it down 1 unit. And what do you think the negative sign is going to do? It's going to reflect it over the x-axis. Alright, so let's do a reflection first. So let's take this graph for this line and reflect it. So it's like a flip. So let's flip this. So it would look like this. If I took that line, the black line, and reflected over the x-axis, it would look like that. Okay? So we did the reflection, the negative. And then the plus 3 would take the graph and move it 3 units to the left. 1, 2, 3. And then the -1 will move it down 1 unit. So that would be the new location of my graph. Okay? We still have one more family to look at, but we'll save that for tomorrow. So I want you to practice these families first in this lesson today.